If you can master and explain this animation, you can solve the LeetCode's three-sum problem without any hesitation. In this video, we're going to talk about how to use the two-pointers method to solve this problem. So the question is question number 15, three-sum, and we're given an integer array nums. Return all triplets I, j, and k in a list such that these conditions are met. And then also, when we add these three numbers, num I, num j, num k, it's going to have to be equal to 0. So for example, example 1, we're given the nums array, these numbers, and then output is a list of lists, and we have two triplets. When you add them, -1, -1, 2, it's going to be 0. When you add these three, it's going to be 0. So the question is asking us, when given an array, find triplets whose addition equal to 0. So how do we solve this problem using the two-pointers method? First, let's go through the code line by line, and then we will visualize it. Let's start with the definition, three-sum. We're given the nums array. So the first thing we're going to do is we're going to sort this array. It serves two purposes. First, it helps us check duplicate values because the duplicates are side by side. Second, it's going to help us use the two-pointers technique because the two-pointers technique will work on the sorted array. Okay, then we're going to visualize the results array. It's going to be empty first, and this is what we're going to report at the end. And we're going to initialize another variable, the length of the array, because we don't want to write this over and over again. It's just n. Okay, and then we're going to loop through the entire thing using I. And this variable I is going to be fixed. So we're going to fix the first element, and then the last two element is going to use the two-pointers technique. That's how we're going to use the two-pointers technique, because the first element is going to be fixed using this variable I here. Fixing this I, and we're going to loop through the entire thing from the zeroth index all the way to the end. We're going to first make sure that this I is not going to repeat itself. So I is bigger than 0, and then nums I is equal to num I minus 1. So it's checking this I with the previous I, and if they are together, if they're the same, it means that there's a duplicate. If there's a duplicate, we don't want that. We're going to skip that. So we're going to do continue. So these two lines are basically meaning that if we have duplicate, skip it. And then if there's no duplicates, after I, we can do our two-pointers technique. So we're going to do left pointer and right pointer, and left pointer is going to point to the element right after I, which is going to be I plus 1, and then our right pointer is going to be at the end of the array, which is going to be n minus 1. Okay, so that is our left and right pointer, and we're going to loop through this part of the array, so the left and right part. So while left part is less than right pointer, so this is the two-pointers condition, global condition. While this is true, we're going to do the calculation S. So num I plus num left plus num right, these three things will be added. This is what the question asked us, and it has to be 0. And then when it's 0, we're going to report it. So we will have three conditions. This S could be equal to 0, it could be bigger than 0, it could be smaller than 0. So we will have to consider those three conditions. So the first condition is if it is S is equal to 0, we find our triplets. And then after we find our triplets, we're just going to append those three numbers into this results list. So that this is our result. After we find our triplets, we have to move our left pointer by 1 and then our right pointer towards inside by 1 to make sure that our search space is reduced to find another or other triplets that exist. After this, we have to make sure that we are actually checking for duplicates. So we checked for duplicates for the first number, and we have to make sure that there are no other duplicates. So we will use while loop. While the left side is less than right side, this is the same as this condition here. So this is a global condition. And we have to make sure that this current left is equal to the left minus 1. So we're checking if our current value is equal to the one before this. So if that's the case, we have a duplicate, so we have to skip that. To skip that, we will just move the left pointer by 1, left plus 1. And then because we have moved the right pointer to the left by 1 too, we have to do that for right pointer. We will do the exact same while loop for the right side this time. So the first condition is the same, left part is less than the right part, and then the current right is equal to the prior right, so right plus 1. So if this is the case, we found duplicates and we're going to move the right side to the left by 1. So we are skipping the duplicates. So these two lines are basically skipping the duplicates after we move the left side and then right side by 1. This is the case when we actually find our triplets when s is equal to 0. So what if our s is greater than 0 or less than 0? Let's first take a look at when s is less than 0. When s is less than 0, it means that our sum is actually small. We have to make sure that we have a larger sum by moving the left pointer by 1. So we'll just do left plus 1. Else, when s is greater than 0, we will do the opposite. We will move the right right pointer to the left by 1. So this is all we have to do. And at the very end, we're going to just return the triplets results list. This is the entire logic. Let's quickly review. So we will sort the entire array, and then we're going to fix the first number. And then for the next two numbers left, we will use the two pointers technique using the left and the right pointer. And then when we will do this three sum for within the two pointers. And then we will do three conditions when s is equal to 0, less than 0, or greater than 0. If it's less than 0, we're going to move the left pointer by 1. If it's greater than 0, we're going to move the right pointer by 1 to the left. And if it's equal to 0, we're going to report it, and we're going to, within that search space, we're going to reduce the search space, and we will also have to remove the duplicates if we find duplicates. So that's the entire logic. And then now we're going to visualize this logic using a very specific example. Now let's quickly visualize this entire process using this one example. So this is the given array. The first thing that we're going to do is we're going to sort this array. And then this is the sorted list right here. So we'll sort it and we'll initialize everything that we need to initialize. And we're going to first start from the fixed, we're going to fix the first element, which is I. I is going to fix the first element, and then the next two element is going to go through the rest of the array to use the two pointers. So, but first thing that we need to do is we need to check if if there's no duplicates, we're going to initialize the left and right pointer. So the left pointer is right after the I, and then the right pointer is at the very end of the array. Okay, so after this, we're going to sum these three things. So after addition, if the addition is less than 0, we're going to move the left pointer. Currently, it's going, if you add them, it's less than 0. So we're going to move this left pointer to the right by 1. So we are going to move that. And then we're going to check that condition again. So the -4, -1, 2, when you sum them, it's going to be less than 0. So we're going to move this left pointer again. So it's going to move to 0. And then when you add these three now, it's going to be still less than 0. And it's going to move to the right by 1. When you add this now, it's going to be still less than 0. So we are done with the two pointers part now, and then we have to move the fixed part by 1. So this I has to move to -1, and we will have to repeat the whole process again. So now let's do it. So now the I is pointing to -1, and we have to move through, we have to do our two pointers starting from -1 and then 2. So we will do that, and then when you do this first addition, -1, -1, 2, we found our first triplet. So we're going to report that. So we found the first triplet, we report that, and then we're going to move this left to right by 1, and then right part to the left by 1. And then during this process, we also check if there are duplicates or not. So we will do this, and then when you add these three now, it's going to be 0 again. So we found our second triplet, and we're going to report that. So we found it, and we're going to report it. And then we're going to repeat this whole process over and over again when I is basically done going through the entire process. And then this inside that loop, these 2 pointers will keep happening until we find another triplet towards the end. So we will do that. We will go through all 39 steps towards the end. And then at the end, this is our answer. We found 2 non-duplicate triplets from this array that adds to 0. And this is how we use the 2 pointers pattern to solve this specific problem. So now let's copy this and then paste it into LeetCode to see if it actually works. Let's copy the solution and test it. So our code has been accepted and it ran successfully. This is how we use the 2 pointers technique to solve the 3-sum problem. Hopefully you learned a lot in this video. In our next video, we're going to talk about another very important coding pattern. It's called sliding patterns. So if you're interested, please stay tuned and happy coding. If you like this content, please subscribe and check out other similar videos.